welcome to test hints for Chapter 1. Thank you, Mr. Topol, for your technical assistance. Okay, so what we do at these review sessions is go through the test hints, and I have a copy of the test in front of me right here with like the real questions on it and stuff. No. But that was a good question. And I'm going to go through and, I'll look at this and we'll go over the test hints, and I'll give you some pointers as to what I think might be helpful to study, or like if something's worded funny, we try to go over that. I think you'll find that this test will be pretty straightforward. I also think you'll be happy tomorrow that you came just to hear today some, okay, remember the wording on this one, kind of a thing, since we decided that we're not going to do test corrections for this chapter. And with any luck, people watching on video, I'll be able to get this posted to Moodle. Alrighty, so the definition of chemistry, I told you right from the beginning in the notes that was going to be the first question on your test. It's like the first objective in the chapter as well. And the question will ask you something like, which field of science studies matter and its composition? Okay, well, if you know the definition of chemistry, you know that that's half the definition of chemistry. And if your choices are biology, chemistry, physics, and astrology, it should be pretty easy to figure out. I would suggest that you take the time to really read the questions carefully. Some of them you'll know like right away, it'll be obvious, but look through all the answer choices so that, maybe one answer choice is worded a little bit more specifically than another. That will be helpful. All right, the second one, define analytical chemistry, means that of those 6 branches of chemistry that we talked about, we're going to ask you about analytical. And the reason we focused on that one, because we could have picked any of them for this test question, is because a lot of what the chemistry that we're doing will be analytical chemistry. And we'll want to know, we're trying to figure out what compounds are there, can this be broken down, can it be combined, and so on. So just looking at analytical is just looking at the composition of matter. So it actually is a takeoff on the definition question, and question 1 can help you with question 2 and vice versa. Okay, and if I'm going too fast in this, just let me know. Describe what chemists study in nature. So this is going to be a question that gives you some like real life everyday examples. And the question itself says, which of the following would a chemist be most likely to study? And then you're going to have some examples. A sailboat sailing on Lake Erie. A rainstorm happening over the lake and creating a waterspout. Water from Lake Erie being zapped with electricity to change it into hydrogen and oxygen. The height of waves and rip currents that develop on Lake Erie. So those 4 choices, which one sounded the most like something a chemist would do? Don't give me that look. Oh my gosh, okay, and what was that?
With the electric current.
Right, if we zapped water with electricity, the water in Lake Erie with electricity and broke it apart into hydrogen and oxygen. That's something a chemist would do compared to maybe a physicist who'd study the waves, an earth scientist who would be studying the weather conditions. A physicist might do the motion of the sailboat and stuff like that. Okay, so think about when you see this question, it's not going to be, the answer choices are not going to be about a boat on Lake Erie, but it's going to be about a common everyday occurrence that you experience in your lives every fall, as a matter of fact. All right, number 4, describe pure chemistry. So we had pure chemistry and applied chemistry. So this question is going to be about the differences between those. So the question itself is another one of those where you're comparing the one kind to the other. So which of the following describes an example of pure chemistry as opposed to applied chemistry? A pure chemistry example would be something like developing a new drug in search of a cure for the common cold. Applied chemistry would be making the compound for NyQuil on a large scale for mass production. So even though both of those relate to colds, one of them is creating something new that hasn't existed before and just identifying a substance or making a substance. That would be more what a pure chemist would do. And the other one is taking a compound that's been discovered and doing something with it large scale. Okay, and again, I'm trying to give you like examples similar to what's in the test question, but I can't tell you the actual answers. Number 5, just explain why we should learn chemistry. Well, this is going to be a question that's asking you which statement is false. So there's all sorts of reasons why we need to know chemistry. We need to make educated decisions about the kinds of products we bring into our homes. We need to be able to look at reports in the news saying, oh my gosh, you know, you can't use this substance because it causes cancer, or versus another advertiser that might say, well, this substance is the best cleaning product ever. And make informed decisions there. When you look at the effects of, like the side effects of drugs and things, since they have to put those in advertising now, to be able to understand what that means and really, you know, well, how serious is this kind of a thing. I think on this one, you're going to definitely need to read those answer choices carefully, because some of the choices do sound very similar, and you're looking for the one that's false. And a lot of times when people get a question like this, they read answer choice A and they're like, oh, that's true, that's what chemists do, and they pick that. But you're supposed to be looking for the one that's false. Okay, so read carefully now. Number 6, oh, Antoine Laurent Lavoisier. It's the one guy I said you needed to know what he did. Does anybody remember? Yep. Yeah, he developed a precise way of measuring that changed chemistry from this mystical, magical, you know, we're trying to find the elixir of youth and turn lead into gold, into a true science that, okay, now we have a way to actually measure the changes going on in these chemical reactions and verify that something has happened, and that was his great contribution. Okay, describe theories. We talked about theories today. Theories as opposed to laws or just ideas. Can you tell me a characteristic of a scientific theory?
An idea.
It's what?
Idea.
It's an idea, but what do we do with it? We test it. It's something we can test, and it's something that has been tested many, many times. Can we prove theories? We can try to prove them. What if we thought we had this proven and everything was set, and then a new experiment happened and it didn't quite match our theory? Then what do we do?
Try to prove it and change your...
We either try to prove it again or
Change your hypothesis.
change your, well, not the hypothesis part. Change your theory a little bit to say, okay, in this situation, this happened. So we can modify a theory. I think what I'm hearing is we're getting a hypothesis and theory mixed up a little bit. Okay, so the testable question versus the theory. Remember, the theory is an explanation. So our explanation of it, and we come up with the best explanation we can, the best theory we can, based on all of the experimental results and what we know at the time. And then if another experiment comes along that shows us something a little bit different, then we might have to modify the theory. Alrighty, number 9, explain, number 8. Identify a manipulated variable. What's the other name for manipulated variable? Independent. Okay, so that is the variable that we're going to set the range, like in the example of taking temperature for every 10 minutes in an experiment. Our range of time is going to be 10 minutes. We're going to record every minute. That's our manipulated variable. And then the temperature is going to change